And we're live. Hey everyone, welcome to Composable, a podcast that takes you deep into Web3's building blocks. And this is Ellie, I'm Alicia, and we're your hosts. And today we're super excited for this all-girl team talking about synchronous composability. And we have Cecilia from Gwyneth. So can you introduce yourself and also tell us what you are doing in the synchronous composability space?
Okay, hi everyone. My name is Cecilia. I work for Gwyneth, which is a subsidiary of Tyco, and I'm an engineer over there. Currently, I'm working on researching within intercluster composability. Literally means within the Gwyneth infrastructure, the interface that we use within smart contracts to synchronously relay messages and also let chain access each other's database and building the transaction within a super builders. Yeah, and on coding side, I currently work on try to stabilize our node because we fork a lot of stuff. Our code base is still kind of in the mess. So yeah, so I have a lot of things in my hand, and um, also preparing for East Denver. So if anyone's going, definitely come find Gwyneth, and can't wait to see you guys there.
Yeah, that's awesome. So today's episode is going to be about synchronous composability, but specifically, we're going to try to be defending synchronous composability because there's a lot of people who think it's overrated. So we found a couple of tweets that I will pull up. So this first one is from Vitalik himself saying that synchronous atomic composability is very overrated. Like, think about what are some specific cross L2 things you are already doing or envision yourself doing that could be more seamless. And I didn't include the rest of the tweet, but he goes on to say that all of this can be solved with async composability. We have another one from Mike Ippolito, which is that there's no line of sight to universal synchronous composability, and it's not going to take off in the year 2025. We have a third one is we have Orist from T1 saying, where in the roadmap is synchronous composability a key piece? Basically, the context is he's saying, why do we have to prioritize synchronous composability over other stuff? And then the final tweet I have from Arjun, which is, ecosystem-wide synchronous composability is both a pipe dream and not very useful in the medium term. So that's kind of the context today. We're going to be saying, kind of defending synchronous composability and just diving a little bit more into it. So before we respond to these specific tweets, let's just kind of chat about what does it mean to be synchronously composable. So I don't know, Cecilia, if you want to offer us a definition of synchronous composability.
Yeah. So I guess let's start with what is being synchronous, right? So in web programming, if you write JavaScript, you remember this function declaration saying async blah 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 blah. And then if you have an async function, you have to await for it. That's because your browser is sending things across the internet and waiting for a response. And this declarative allows the code to parallelize the other section of the statement that just skipped across this await the things that are still awaiting the response, right? So that's coming from the asynchronous nature of any messaging protocol, where processes are happening at different places, right? Like my code is running on my browser, and the other server that's supposed to respond to me is running on some other AWS server that I'm waiting for it to respond to my transaction or a message, right? So that's the asynchronous nature of how things happen, which also is how blockchains or layer 2 work nowadays, because it's literally executing on different chains, right? So if I relay a message to some other chain, I basically need to wait for the consensus mechanism to converge on my end and the other side, no matter if it's a rolled up or a layer 1. However, in the synchronous case, um, then like the entire process are basically executing in one system in one VMs, right? So that basically imply either share sequencing or like what Espresso do, like coordinated sequencing, or after you do stuff, you enforce share settlement together so that this execution result, so that like at the for the developer, you can write synchronous code, and on settlement everything settles together, that like we settle whatever that you promised to the developers and or the user. So to me, that's what synchronous composability is.
Yeah. The way I like to, my mental model for it is that when we have smart contracts today on Ethereum, like those are synchronously composable with each other, and we don't really even think about it. But if you tried to have smart contract calls from, Ethereum to other L2s, you don't have the same experience. So we're trying to replicate the experience of a single chain, but across many chains.
Yeah.
Yeah, I think that's a great explanation. Like, I love the way that you brought it to just regular programming. So, if you're listening to this, even if you are in Web 2, you do know the concept of a sync and waiting for a process or having everything happen in lockstep. And it's like really difficult in the blockchain space because it's not just about, okay, I need to wait for this other system, but this other system has a whole different consensus algorithm, which has different rules. Let's say you're waiting on an optimistic system and it has a fraud proof window of 7 days, and you're trying to synchronously compose with the ZK layer 2, which has a shorter proof time. So then you're like, okay, so do I have to wait 7 days so that the entire transaction can happen at the same time? So it definitely isn't straightforward when trying to work out how to build a synchronously composable system in the blockchain space.
Yeah. Well, this is a really good segue to, so a lot of people talk about synchronous composability, and like, why don't we already have it? So why is it hard to do? And you kind of touched on this already, Cecilia, but I don't know if you have any other comments. Like, why is it such a hard thing for us to get synchronous composability in the first place?
Yeah, I think first of all, like Ethereum is what it is now, because like we are very fragmented. We have a lot of layer twos, and different layer twos has different security assumptions, and it's like also from a marketing standpoint, everything is a wall garden, and from an engineering standpoint, we have a lot of artifacts that are built at different point of time. There's a lot of legacies, right? Like it's very hard to unify everything, especially me, since I work in like node integration. I know how hard it is to like make it backward compatible, right? And so like if we're talking about building transactions together in a shared sequencer, that basically means there's this one piece of software that needs to be compatible with all systems. Or if not, then like you have to have like either sidecars or whatever, right? And then you have to make them communicate with each other, and then like establish like channels, set up, the networks and all that stuff. I don't know, it's just like a lot of work to do, right? It requires a lot of BD beforehand, and on top of that, a bunch of engineer that comes afterward to actually build the stuff. So yeah, it is very hard
Mhm.
across cluster, I think.
Yeah. And I mean, one of the reasons that we wanted to have you on is because recently Tycho Gwyneth did what I think is the first demo of synchronous composability actually happening, which is really, really cool.
Hmm. Yeah, I mean, but like that is intercluster, right? We have everything under our control. We don't have the depth that are from like Arbitrum, the OOPs, or like whatever. We don't use their forks. We just fork Reth, right? And within Reth, our CTO and me and the other engineer, we just like do whatever we want, and that's why we can ship things very fast.
Mhm.
Um, yeah. But thanks for watching our live demo. That was
Yeah.
fun. Very
Mhm.
fun.
Yeah, and we'll link it in like the show notes if people want to watch it, which it's really cool. So I'd recommend.
That's interesting. So, what work do you think would have to get done for you to take what you guys shipped for your cluster to then extend it to one other cluster, let's say Arbitrum?
Hmm. Hmm. I think so. First of all, Arbitrum is not based, right? Um,
Fair.
we we implemented everything with the assumption of base rollup, and we built everything against um, each new L1 fork choice update. And as far as I know, Arbitrum has their pre-confirmation, or like they just give like instant confirmation because I I don't know if it's fair to say that they're centralized, but like I mean like it's like instant finality, right? Like you transact on Arbitrum, like the result is out in what, like 250 millisecond.
Yeah.
Um, I haven't looked at their code, so I don't know how their blocks are built, right? Probably in some AWS, but cool, it's cool. Um, yeah. So I don't know. I think it's very hard to integrate, and I don't even know like what software they use. Like, do they use Geth or do they use Reth? But we use Reth. I think it will be easier to try it out with OP, with the OP stack, because a lot of our code, all of our some of our design is similar to OP's, and I think they're down to become a base rolled up, which
Mhm.
means in a base rolled up infrastructure, if everyone is base builder, I guess we can put our super builder there to do something that's like synchronously building with theirs, with like some partner within this OP super chain ecosystem. I think that's possible. Yeah.
Interesting. I think that's really good insight because as you were describing what makes it hard for synchronous composability, I was thinking like, damn, if it is that hard, then why should we bother? And then you explained how, with the example you guys created, is in the cluster. So therefore it's much easier because you have control over at least the way things are implemented. And I think maybe cluster, like in cluster, synchronous composability is a much more achievable goal than synchronous composability across chains. And I think that's okay for now, because at least I would give developers enough time to figure out like, what can I build with a synchronous composability? If they unlock some new financial paradigm and people are like, this is so amazing, we need to see this across multiple types of clusters, then people would put the engineering resources and the BD behind to building it. So I think that's interesting.
All right. Should we segue into our portion where we're going to defend synchronous composability? Or maybe not defend it. We'll, I guess, give our opinions on if it's overrated. So we got a few spicy questions that we're going to discuss. The first question is, if we all work together to have Ethereum united, which combination of protocols would get us there fastest? So I'll answer first, which is that I think synchronous composability is probably not going to get us there fastest. I don't think that means it's not worthwhile, but doing things like intents or other asynchronous versions are faster just because they're a lot easier to do. So, that's my opinion. But I think that synchronous composability is very important for like the long-term interop game of Ethereum.
Yeah, I think definitely there are a lot more people that are working on the intent side, or like try to standardize the intent based message passing, framework. But I think like honestly, the best way to build synchronous composability is to ship a POC, right? Which is what we're doing right now, and we ship it and we try to like BD or integrate any other partner. Um, Hopefully, one of the base rolled up, which will be easy to integrate, right? And then we ship another POC. And I think like an upside of the entire ecosystem is the fact that base rolled up is taking off.
Mm.
Um, so I think as that takes off, we'll have like base pre-confirmation, and there will be a bunch of pre-confirmation gateway, and we can do synchronous block building or share sequencing at the gateway level. Yeah, so in fact, Taiko's first preliminary support for base rolled up um, has a gateway being our sequencer, right? So if you think about it, Gwyneth is going to use a gateway as well, because we have to be based. That means we have to use pre-confirmation. That means we'll have to either integrate with a gateway, or just let our sequencer be the gateway, that sequence for L2 transaction. And if some other, base rollup or base stack use the same gateway, then we can potentially synchronously compose with them, right? If both party agrees to support the same interface.
Yeah,
Yeah.
just if some people don't know, based sequencing is when you have the Ethereum L1 proposer sequence for you, which is a really cool idea. And so yeah, Tycho Gwyneth is a based rollup, as well as some others.
Yeah. Yeah.
Cecilia, I'd just like you to explain what you mean by gateway in this example.
Oh, that's hard. Uh, uh, okay, a lot of people has different definition of gateway. So in Justin Drake's first envision of the gateway would be like kind of like a router or like a relayer type of thing that relays
Hmm.
pre-confirmed transaction to the validator, so that the validator can issue pre-confirmations. Um, in our case, if you think about it, if a L2 transaction is pre-confirmed by some party, that means all these transactions has to go to this software entities, which has to sequence it and then send it to the validator to come to issue pre-confirmation as a batch, right? Then this gateway is basically our node, right? And in
Okay.
fact, we do like give, like the pre-confirmation protocol, we give do like, send our repository to them, that is our node. Yeah. So
Nice.
yeah, it's very interesting. I think like in the future, we'll have to see how the engineering, effort evolve. We'll either like get it separate or get it integrate. So I don't know like which direction would it goes.
Yeah, I don't know. Alicia? What are your opinions?
Okay, so if I think about which protocols have to come together to allow us to unlock synchronous composability, we definitely need like a few L2s who are willing to allow us to have some level of shared sequencing. I think that has been one of the hardest things because a lot of rollups want to keep their sequencing power. But if you don't have that visibility or that ability to ensure that you have all of that happening at the same time, or at least few of it, and you can confirm all of them at the same time, it's kind of hard to give any kind of guarantees about what's going to happen next. And I think a protocol, and I don't want to call protocols names because I don't know who will be willing to do this. So I'll just say a protocol who does X. And I think a protocol who does cross-chain message passing really well, I think it'd be good to have them integrate and collaborate, because then they would need to make use of these rollups that do allow us to use shared sequencing. So we have a bunch of rollups who are like, yeah, I'm game for doing this. And maybe they might be L3s, who knows? And then we have a cross-chain messaging protocol who is able to see that, I can do cross-chain messages because I already have the contracts on chain. I already have this external verification network. And then maybe BD, the best BD people out.
No, this is great because this is like a good segue into my next question, which is who is ever going to agree to use a shared sequencer? And that's kind of coming from like shared sequencing. It's such a cool idea. We get all this composability, but chains don't want to actually agree to do this. Like no matter how much BD we do. So in my opinion, like I think this is specifically where based rollups like are really good here, because just by definition, based rollups all share the same sequencer, which is the L1 proposer. So I think that synchronous composability will probably take off the most with based rollups. To be really honest, I think it'll be really hard to get non-based sequencers or non-based rollups to share a sequencer. I think that we might be able to get it like inter-cluster potentially, but I think mostly we're just going to see it on base rollups. I don't know. What do you think, Cecilia?
Yo, I wonder what's your take with like intercluster, because like I mean, Espresso is working on coordinated sequencing, right? Last time we talked about
Mhm.
the CERT, right? I think like I just give you my take regarding pre-confirmation. I on my end, as long as I'm seeing base rollup taking off and they're forking Taiko, then I'm good to go, right? Yeah. But so that's what I'm curious about. How will you guys tackle this, right? Like for
Mhm.
chord sequencing.
Yeah. Yeah. So it's a tough problem. Just like synchronous composability, it's just a really hard problem. In my mind, real like not all rollups are going to be able to be synchronously composable. Like all based rollups could be synchronously composable if they wanted in theory. I think non-based rollups, we're going to have we can have synchronous composability across clusters, and we can and things like that. But I think it'll kind of be on more of a pairwise or like group of three rollup basis where these three rollups who are very closely connected just due to the nature of their rollup will be synchronously composable, but they won't necessarily be synchronously composable with like OP, mainnet or base or something like that. I It's my hope in the future that we can get more synchronous composability. So personally, I kind of like the idea where maybe you don't have to share a sequencer all of the time, but you can share a sequencer like every so often for people who want to do synchronously composable things. Um, and I like the idea that you don't have to lock into like a specific roll up that you're sharing your sequencing with. So, like, one block you could have a shared sequencer with Arbitrum, and then the next block you could have a shared sequencer with OP. I think that that's my ideal future, but I do recognize it's going to be really tough to get there.
How like can you like explain how is it possible for like one block you do it with OP, the other block you do it with Arbitron? Is there any like POC or anything
Yeah,
that Espresso's trying?
yeah. So Espresso doesn't have a POC on this yet because we've been working on some other things. But yeah, the idea is that you would need to the rollup that wants to be synchronously composable would need to be okay decentralizing their sequencer. And so you could do things like you could do it a couple of ways. So one, the rollup could just say like literally every other block I want to be shared sequenced with Arbitrum or OP. Or you could do it on a more dynamic basis where you run some sort of auction or market and see like which roll up is the most valuable for you to be shared sequenced with, and then you are shared sequenced with that roll up maybe for a few blocks, and then you run the auction again and you say, okay, now it's more valuable for me to be shared sequenced with this other roll up. That's how I envision it happening.
So you do think that like decentralization is a necessity, like is necessary for rolled up. Okay.
I think yeah, so I think decentralized sequencing will be necessary for smaller rollups who want to like synchronously compose with other rollups. I think it would be a long time before we get some of the major L2s to like agree to share a sequence, like to give up their own sequencing rights. So I think it'll kind of be mostly a one-way thing where like I'm a really small, nitro chain. I want to be synchronously composable with Arbitrum. So I'll let Arbitrum sequence for me, but like Arbitrum, isn't going to let me sequence for them.
Yeah, yeah. They probably have their own intercluster solution.
Mhm.
Uh, yeah, I think like as base rollup evolve, honestly, like in the future, the easiest way to launch a rollup or an application. Now I'm seeing the two concepts being blurred together, being blended even more because you have like application specific sequencing, and that's just one step away from being based,
Mhm.
right? Um, and if app and app chain and rollups are, intermingle, then the easiest way to build an app that gives your user the best UX is using base pre-confirmation. And I feel like if I were to build an application in 2025 to 2026, I would have picked this route instead of deploying another smart contract and pay L1 gas fee. Right. If we have enough validator on board for pre-confirmation protocol, then we have a good foundation to do more intra-cluster synchronous composability, but in the base within the base rolled up framework. Yeah, so that's my take.
Mhm. This is a good lead into a next question, which is like synchronous composability is really hard, which we've talked about. And is it even worth it if like not all chains will have it and only a couple of chains will be synchronously composable with other chains? Maybe Alicia, you can give your hot take.
Well, I mean, honestly, we had this conversation before, Ellie, and I don't think I am so pro synchronous composability, not because I don't like the idea of what it can give us, but more from the POV of from the end user's perspective, they just want fast transactions and they don't care who takes the risk once they don't have to take the risk. So as we saw with intent bridges, like you are getting really fast crushing experiences and they're taking the risk. And if you can use an intent bridge protocol to do even more things than just bridging, then that'll for the users POV, they're saying like, oh yeah, I bridged, I bought an NFT, I loaned it, and all of this was in one transaction, and it's because of intents, but they don't care what the infrastructure is. So I guess, is it worth building? I like the idea of building it and I like the idea of proving that it is worth building. But right now, I can't say like, yeah, 100% like people should aim for this unless you can prove, or unless through building it, you can prove like, you know what, we're actually getting more economic value from it. Because I think that is some of the reasons why, L2s aren't allowing you to share their sequencer because they're like, yeah, it sounds promising, but right now we need to make sure that we are profitable. Like all of us in Web3 are trying to build profitable businesses as well. And I think that's part of the reason why we don't work together as much as we would like to, and why they don't want to share their sequencer. I think in theory, when you meet the founders and BD people at these protocols, we all get along and we all want to work together, but realistically, we have to just make sure we create value economically. So I think for that reason, I think intent bridges gets us far, but I do want to see what, in cluster synchronous composability would do, just because it is not that hard. And no, I wouldn't say it's not that hard. It's not as hard as actually, doing different clusters. So therefore that should be able to help us prove some concepts instead of taking the resources to do it across multiple ecosystems.
Yeah, no, I agree with that. I think I'm very excited for synchronous composability, but I think that we won't really know if it's valuable or not until we actually have something deployed. My hope is that it will be, and that it'll unlock a lot of new use cases. But yeah, I think it could very well just be that, intents can do 90% of the things that we want to do. And the complexity of synchronous composability isn't, maybe it's not like, it's not worth a chain deciding to share a sequencer. Like a chain isn't going to say, well, I get so much from synchronous composability that now I'm going to share my sequencer. I think that it's a realistic future. I just hope it's not the future.
Well, I kind of have an answer of what it can potentially achieve from like an application standpoint. I actually have a repository if you want to check it out. So like we actually have a
Nice.
cross-chain Uniswap, literally. So
No
like
way. Share
yeah,
it.
I'll send it later because I have to look for it. So yeah, so it literally let you tap into L1 liquidity from L2, right? Imagine you're an L2 user and then you have no money on the L2, but then you want to swap on L1. You don't need to like do anything. You just literally swap on L1. You can do like let's say you have like USDC on L2, but you want to swap, but then the pool and USD of on L2 is dried. You don't have any liquidity. So you like swap it on L1 and then bridge it back within one block, right? Without like paying any other bridging overhead, without waiting, without you literally just have that transaction to one click. And we actually have that. Like in fact, in our demo, I think we demonstrated that front end. I think like it's very powerful because you're in that case you're literally using L2 as a executor, right? And this is literally sharding without bridging your liquidity to the shard, right? I think L1 should still have the most valuable assets, and you can just use, like, I think layer 2 are literally the extension of Ethereum, right? And now the thing is, the extensions are drawing out either liquidity or economic value from L1, that like we fragment the entire ecosystem. But like solution like Gwyneth, um we kind of like, I think in the future how I will push our developer to build on Gwyneth is build apps such that it does these things that allows people leave their money on the most secure place and only use L2 for execution. And we batch your execution, we prove your execution, we synchronously compose with your liquidity on L1, right? um and also like there's a lot of other powerful things that you can do, um but like that like you have to like look for an application builder that's specialized on this, that like I was actually playing with our interface yesterday, that you can literally, um like our transferring function allows people specify from chain A to chain B, from what address to some other address, just like with one click. But imagine like what else can you do with this? Like for example, you can do like cross chain landing like seamlessly, or like just like use any functionality like executes at this place, but then leave your liquidity on some other place, or just do all those fancy stuff. I don't know, like, cause I haven't been writing smart contract for a while, but I do think that like for swapping or like any economic purpose, um, you can have a lot of fun with it. I think, yeah.
Yeah. Actually, I think this brings up a really, really good point, which is that, you can have synchronous composability between L2s, but like also a really powerful case is having synchronous composability with the L1. And I do think that synchronous composability with the L1 is like the most powerful form because, with other L2s that are not based, you can get very, fast confirmations. You could do very fast asynchronous interoperability. On the L1, it depends on what you want to trust. So you could still get good interoperability with like pre-confirmations. Um, but since just by the nature of it, the L1 doesn't actually have fast finality, I think that synchronous composability is really, really important for exactly what you said, which is accessing liquidity on all of these other chains. Um, yeah, my prediction for the future is that synchronous composability with the L1 is going to be the biggest use case.
Yes, I agree. I agree. Actually, I'm gonna talk about that in my presentation in Denver in
Oh,
the
Oh,
awesome.
nice.
event. Yeah.
All right. Let's see. What is another spicy take? Oh, did you have one, Alicia?
Yeah, I just have one question around
Mhm.
speed. Ellie and I did an episode, and we were so shocked at how fast intent bridging was. Like, we don't really use it normally. I normally use a canonical bridge for whatever reason, and it's super fast. So, with synchronous composability, like how do you predict the speeds to be, or do you have an example from the POC that you guys created?
Hmm. That depends on your implementation, right? For our latest iteration, I think combined with pre-confirmation, we can basically achieve like uni-chain level synchronous composability. Because like what we're gonna do is we put all transaction in a super transaction as we propose. And prior to that, as you sequence, as long as you secure the state lock of L1. Let's say like, okay, let's say but then like the premise is you have to have kind of like app specific sequencing, right? You have to lock the state of this specific smart contract that like it doesn't move for a period of time. So okay, like L2 can access these set of state, um before we propose, right? Let's say these are the two time frame of the proposal. And then for this period of time, this specific contract state is locked. Then we can interact with this contract freely. And as we interact with the base pre-confirmation solution, depending on how fast the pre-confirmation protocol is, we will be like at least as fast as the pre-confirmation protocol, that we like go back and forth like between us and that specific set of state, right? But then we can't guarantee that with the entire L1 because it's not realistic to secure a state lock for that long. Yeah, so it depends on base pre-confirmation basically, if because like our solution already allow us to go back and forth between L1 as much as we want during our state lock period.
Interesting. I like that.
All right, maybe one like last spicy take before we wrap up. So I've seen several people on Twitter say that if you're doing synchronous composability and you're sharing a sequencer, that means you're just one really big roll up. And so you should just be one really big roll up. And what's the point in being two roll ups? So my take on this is that I don't think it means that you're one big roll up, because you can still have each roll up have their own VMs, their own branding, like their own governance, all of these different things. And you also don't have to share a sequencer all of the time with all of these other roll ups permanently. So, in my sense, no, sharing a sequencer does not mean that you're one big roll up. But I'm curious to hear your thoughts.
Again, like if I go back to my base thing, because I'm all about base. Yeah, so like back to the base ecosystem, if like Ethereum, the native layer infrastructure is sequencing for everything, isn't everything a rolled up if you think about it?
Yeah.
Right. We are basically using the existing PBS pipeline and the existing builder framework to build L2 blocks, right? It doesn't really matter which L2 does it belongs to. I envision future base rolled up as domains, right? Like when I'm working on our node, I will see like L2A and L2B bundling up as one proposal proposing to L1. You can view that as a big roll up, but I view it as two separate domains, right? And then like I can also configure on my infrastructure saying, okay, for the next several blocks, I'm only going to sequence for L2A and leaving out L2B. So the chain.
Oh, no, I think your audio cut out, Cecilia.
Oh,
No, we still can't hear you.
Oh. When she said she's all about the bass, I was thinking, I'm all about the bass, no trouble.
This is fair. Last week I had microphone issues and I thought it was my microphone, and then it turned out to 110% be user error, and I was accidentally just hitting the mute button on my microphone.
Okay. Am I back?
Yeah,
you're
back.
very back. You're so back.
I'm so about the bass. I hear you saying. Yeah. So I was saying, from which part I got lost?
The last word you said was chain, but I mean that's probably every other sentence.
Oh,
I know, right? That doesn't help.
You were saying how like the roll-ups are different domains, and like that's how you view them.
Right. Yeah. In my view, the roll-ups are different domains, and like for example, like in my infrastructure, in my local setup, I can literally configure such that for the next few blocks, it only sequence for A, but not sequence for B. So basically, the chain that doesn't have liquidity will die out. Like it will have liveness issue, right? And it doesn't mean that like all of the chain are always sequenced together. It's like opt in and opt out, right? Or in that case, would you consider that they're all big roll up? No. It's like if google.com has a lot of traffic, then it lives. If like Facebook, no one uses Facebook anymore, it dies. Right. And everything is using, a base infrastructure, being on like AT&T, like in like the lower tier of networking infra. Yeah. So like that's how I envision this. Um but in one sense, like Ethereum itself is a big roll up, right? Like what Justin Drake said. You consume different services where Ethereum has to provide either, DA execution. What else? Uh, I forgot. But yeah, I think like from a base rolled up standpoint, we're basically consuming execution, right? If everything's are indeed based.
Yeah, I like that. I like that framework of like consuming different services from Ethereum.
Yeah. Yeah.
What are your thoughts, Alicia?
I mean, I don't necessarily agree. And I think that if you are a roll up and you are making use of a DA layer, for example, and another roll up is making use of the same DA layer, it doesn't automatically mean that you guys are the same roll up. So I think similarly, if you have shared sequencing or you both are using Ethereum as your pre-confirm or your confirmation layer, your settlement layer, it doesn't automatically mean that you are the same roll up especially because not all activity as well is cross chain, but you are depending on that to figure out whether you settle. So yeah, like you still have a reason to exist because maybe you have some specific rules, like maybe your gas fees are quite cheap compared to another chain. There are many different reasons why you would still exist and participate. So yeah.
All right. All right. So those were, hopefully we touched on a bunch of generally spicy takes or the general criticisms that people have of synchronous composability. I'd be curious to know what people think, if they think it's still overrated or if they think it's cool and we should still keep working on it. All right.
It
Yeah.
just depends on you guys.
Okay. Yeah. Thank you so much, Cecilia, for joining. This was really wonderful.
Thank you guys.
Thanks.
All right.
Bye.
Bye.
Bye. Wait, is the live stream